again, for those who are at home, we're not going to be using our textbooks. This is all unit totally separate from this book. And it is, for the most part, I'm getting the information from another book, but I expect that as the week goes on, I'll be making things totally up. So, and not like fictitiously making it up, just creating things on my own. Okay. So today we're going to talk about solving problems related to the basic counting principle, distinguish between independent and dependent events, and then solve problems involving permutations and combinations. And so the choice of selecting a mathematics course does not affect the choice. Oh, let's skip on to this. Let's slide down to here. I should have put this up in front of the other. Sorry about that. Says you are setting a schedule for next year. You have the following choices for each class to choose from. There's only one math class for you. That's predetermined. But there are 2 English classes, 2 science classes, 2 history classes, and 2 gym classes you can choose from to create your 5 classes. Okay? And so what we're getting at is, and this is a tree diagram, and that says that up above what it's what we're looking at here. And so right here I'm going to write math, and we only have one math class to choose from, so that's why we only have one option here. Okay? But when we go over to the next class, the English class, I have how many to choose from? 2. So here I could put my English 1, or I could choose math and then English 2. Does that make sense? Okay. So right now I have either math and English 1, or I have math and English 2. Those are my 2 classes I've selected so far. So if I go on to the next class, I have 2 science classes to choose from. So if I go math and English 1, I could go science 1 or science 2. Or if I took math and English 2, then I could take my science 1 or my science 2. Is this making sense? How we're creating this tree diagram? I'm asking the wrong question. Is this not making sense to anybody? I know vacation just ended, and we're all a little sleepy and rather sit around and probably have our game day. We'd rather have our game day today than last time we met. But we got to get moving on this stuff. So right now, one of my options is I could take math, English 1, and science 1. Right? And then from there, I choose from my 2 history classes. And so let me undo that. And so I could have history 1 or history 2 here. Or I could have taken math, English 1, and science 2, in which case I still can choose from history 1 or history 2. Okay? Or I could go down here and take math, English 2, and science 1, and then take what? Louder, please. History 1 or history 2. Or down here I could have gone math, English 2, science 2, and I still can choose from either what? History 1 or history 2. And what do you think is going to happen on the far end of my tree diagram? I still have one more class to choose from, right? And so what is it? Gym. So I either have what? Gym 1 or Gym 2, right? And that's going to be the same all the way down here. it says, list all the possible schedules. So, can anybody look at it right now and tell me how many we're going to have? Anybody look at that right now, just the way it is, and say, how many schedules am I going to have? Possible schedules. 16? Did I hear 16 or 16 maybe? 16? Okay. Let's check it out. What's one of our possibilities? Let me select a, we'll go over this and highlight. What's one of our possibilities here? Doesn't have to be the first one or the last one or the middle one. Just pick one. I don't care. What could have I taken? Yeah. So you say math, English 1, science 2, history 2, and gym 1. That's right. There's one of my possibilities. Okay? So they want us to list all of them. So I want you to take a minute, and in your group, I want you to list them all. So this is going to be, just if we listed that one, I would write math, history 1. I'm actually not going to use, let me try that again. Math, English 1, not history 1. English 1, science 2, history 2, and gym 1. So that's how we're going to list one. Okay? So I want you to take a minute with your group, or by yourself, and your group if you need help, however you want to work it out. I want you to take a minute and list all, you're right, 16 possibilities that we have there. So list them all here. Should have lots of room there to list that. Okay? Since some of you are working much quicker than others, just to make sure we're understanding what's happening, what's another possible connection I could make here? What's one more possible one? Someone give me an answer, please. We did math, English 1, science 2, English or history 2, and gym 1. What's another possibility? Let's go in the bottom half here. What's another one I could do? Go ahead. Okay, good. And if we're doing everything in order, that'd probably be the very last one I did, wouldn't it? Because the one before it might have looked like this. Right? Okay. Just wanted to make sure we knew what we were doing. Some of you seem to be staring a long time at this. Okay, we don't really want to spend any more time on this. Either you've got it done or you've got a pretty good idea what you're doing. There is, you know, if you were doing this, if this was a test question, you're required to do this, and you drew your tree diagram or you had a tree diagram, you would probably want to start here and say, okay, there's 1, and then follow the same path. There's 2. Then we go out here. We've already covered that one twice, so we go down here. There's 1. Follow the same path again. Down there, there's 2. All right, so now we have 4 done, and just keep going. So these are all done. Up here are all done. So then the next one we drop down here and go 1 there, and then there. And then those 2 are done already, so we come down here now and go to there, and down to there. And so if you go with that pattern, then you won't overlook any. And if you take your pencil and lightly draw a line connecting them, you'll know that when you got out to here every time, When your pencil got out to there, then you were done with that one. Okay? And so that's how some of you probably looked at this right away and said, oh, there's 16, because out here we had G1 and G2 written down 8 different times each, which added up to 16 possibilities. Okay? All right, so now let's move back up here. The classes I chose weren't quite the same. You see they have a humanities class here. Humanities, by the way, are classes that every degree in college requires you to take some of them. Every degree that I'm aware of, anyway. And you might want to check out what qualifies as a humanities when you sign up. I thought it had to be labeled humanities for my first class, and my first humanities class was not one that I enjoyed at all. And then after that, I discovered that since my degree was not in history, then history classes for me would count as humanities classes. So I ended up with almost a minor in history because I took a lot of history classes to count as my humanities. But anyway, just a little bit about the future. Moving back to what we're really talking about here, the choice of selecting a mathematics class or course does not affect the choice of ways to select a science. To make it real to what we're talking about, there was only one math class to choose from, but the way I chose my 2 English classes did not affect the way I chose my science classes. They were totally separate, weren't they? If I chose English 1, it didn't affect the fact that I still could choose Science 1 or Science 2. Okay? If I'm rolling 2 dice, what I roll on the first dice, does that affect the way the second dice rolls? No. They're totally separate, aren't they? Okay? And so what we're getting at is, these are called independent events. Independent because the choices that I make on one does not affect the choice that I make on another. Okay? Dependent events are events that are affected by the choices you make. A good example of that is if I have a deck of cards and you draw out the ace of hearts, does that affect what's left in the deck to draw the second time? Yeah, first of all, there's one less card in here now, right? And there's no ace of hearts in there anymore. So there's one less heart and there's one less ace. Okay? So it's my next draw, my second draw, would be affected by what I got on the first draw. So that would be a dependent event. The branch of mathematics that studies the different possibilities for the arrangement of objects is called combinatorics. I'm not positive I'm pronouncing that correctly, but that's what we'll go with. The example of choosing possible course schedules illustrates a rule of combinatorics known as the basic counting principle. This tree diagram we just used, we can use to show our possibilities. Okay? So we listed all our possibilities. Let's move on to the next page. We're going to look at this a little differently this time. It says you're taking math, English, history, gym, and science. How many different ways can you arrange your classes? Okay? Before, we didn't say first hour, second hour, third hour. We said we're taking one math class, one history, or one English class, one science class, one history class, and one gym class. And we said how many different groups could we have there? Okay? This time we're saying this is first period, this is second period, this is third period, this is fourth period, this is fifth period. Okay? Probably should write period down there. So when I choose my first period class, how many classes do I have to choose from? How many classes am I taking? 5. So how many do I have for that first period class? 5 different possibilities, don't I? Okay? Now, what do you think the first one was? What do you have right now? Math. So say you chose math first period. How many classes you had to choose from now for your second period class? 4. And what did you choose second period? What do you have second period? Science. So she has science class. So how many does she have left for her third period class? 3. And what did you choose third period? Choose a different one. History, okay. And after he chose history, how many does he have left for his fourth period class? 2. See, we had math and science and history. So now for this fourth period class, I can either choose English or gym, right? And so we chose English, and so what's our left for our last one? Gym. Okay? So the basic counting principle says that 5 times 4 times 3 times 2 times 1 will tell us how many different possibilities I have for arranging those classes. Okay, and so what is 5 times 4 times 3 times 2 times 1? 120. Now, do we want to make a tree diagram for that? No, I don't. But we could. And the way we set that up would be very similar. The difference is, if I go back to that page, instead of choosing classes like this, we choose periods. So first period I would have 5. I'd have, let's go down here. So I'd have periods here. Period 1. I'd have 1, 2, 3. Oh no, sorry, let me label them properly. I could choose for math, science, history, English, and gym. Okay? And once I chose math, I could choose history, science, I'm getting these all mixed up, English, and gym, right? And once I chose history, I could choose science, English, or gym. And once I chose science, I could choose English or gym. Right? And so that's what it would look like. My first period, second period, third period, fourth period, and sixth period class would look like this. Okay? Or if I went math, history, science, gym, then it would be English. Or if I went math, history, English, it would either be science or gym. And from science I could take gym, and from gym I could take science. So it's not quite as neat and clean as the one we just did, but it's the same concept. That tree diagram looks something like that. And so we would end up with 120 different paths. And we certainly do not have room or time to list all of them today. Okay? So that's why the basic counting principle, that's why the basic counting principle right here, it's easier to understand, or it's easier to calculate that using the basic counting principle. Another simple way of looking at this is if I was putting my books on a shelf and I had, let's take a second and list all the classes we might have here. Okay? Maybe not all of them, but let's list a few of them. Let's say we have math, we have science, we have English, we have history, we have art, we have culinary, gym, shop, band, thank you, strength. Well, we had Jim here, so let's call JT is gym team games. GS would be strength. Spanish. What's that? Zoology. So, yeah, we could go science, chemistry, science. We list a lot, can't we? Science, biology, science, zoology, science, math, geometry, math, algebra 2, math, pre-calc, math, calc. We can list them all like that. So let's just go with the ones we have here. We have how many books here? If we had a book for each of these. 11 books here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, good, I agree. But our bookshelf only has room for 6 books. And so we have to pick the 6 that we actually think that we might want to ever look at. You know, like your math. Yeah. Your math books, you'll want to look at them, won't you? So we have to pick those books that we want to look at. So on this first spot right here on our shelf, on this first spot, we want to know how many do we have to choose from? 11. And the second spot, how many do we have to choose from? 10. In the third spot, we now only have 9. And then 8, and then 7, and then 6. Did I get all my books up here? I didn't, did I? There's not room for all my books. So how many different possible ways can I arrange that?
What about equals to? Times all those.
What's that? That number fact, no. No, because I stopped at 6. Right? Can someone tell me what that is? What is 11 times 10 times 9 times 7? 8, sorry, I skipped the 8. Nobody has a calculator? 3? Did you stutter or did you say 3 twice?
Yeah,
Okay, 3, 3.
2, 6, 4, 0.
So 332,640. Okay? That's a lot of different arrangements, aren't there? One of them could have looked like this, couldn't it? Math, gym strength, history, I forget what C was. Culinary arts, and how many is that? 1, 2, 3, 4, 5, and shop. Okay? So there's one of them. What if I didn't like that arrangement? What if I chose gym strength, math, art, culinary, shop, history? Okay? Is there a different arrangement? Yes, it is, isn't it? Are they the same books? Okay? They are the same books. What we're getting at here is they're in a different order, aren't they? So the question is, does order matter? That's the question. Write that down on there. You're doing this, right? I'm not doing this for myself. Remember, I gave you a copy of notes, so you didn't have to copy everything down. But what I'm writing up here, you need to be writing. Does the order matter? In this setting, does the order matter? And in this case, it might be up to you. It might be an individual personal decision. It's your bookshelf, right? To me, walking in, I'm going to look up and say, oh, those are your important books. It's not like underneath them it says first place, second place, third place, fourth place. If these were the most popular books, okay, and this book won first place, and this book won second place, third place, fourth place, fifth place, sixth place, that would be different than coming down here and saying this one took first, this one took second, this one took third, this one took fourth, this one took fifth, this one took sixth. Now, if I say they won a prize, then order matters, doesn't it? If I just walk in your house and I see your bookshelf there and I think, oh, those are books that are important to them, I probably don't make the connection that they're in first place, second place, third place order. In fact, you might actually center your most precious one, wouldn't you? I mean, if I walk into Jeffrey's place and there's 6 bucks mounted on the wall, probably the most precious one, the biggest one, is going to be in the middle with the other littler ones looking off to the sides, aren't they? That's probably how it's going to go. All right? So the order really doesn't matter so much in that scenario, where in here when we have a place, then it probably does matter. This is leading on to this question right here. What is a permutation? Okay? A permutation is arrangement in which the order matters. A permutation is arrangement in which the order matters. So if I go history, math, science, that's a different arrangement than history, science, math. Same 3 classes, but it's a different arrangement. So your class schedule probably is a permutation, right? You have math, science, history. That's different than someone sitting next to you has math, history, science, isn't it? Okay? So the class schedule is a permutation. What is a combination? Well, a combination is an arrangement in which order does not matter. First day of class, I let you walk in and sit down in seats, and you chose your groups, didn't you? Okay? Where you sit in your seat doesn't matter to me, did it? You chose those arrangements. So this group, let's pretend this was the first day arrangement here. We had these 4, and it doesn't matter if I listed them 1, 2, 3, 4, or if I listed them 1, 2, 3, 4, or if I listed them 1, 2, 3, 4. Which way I listed them didn't matter. It was this group of 4 people. Okay? And so that's all that mattered. So in this case, the arrangement doesn't matter. That's a combination. Okay? That's a combination. If the arrangement matters, it's a permutation. I should say if the order of the arrangement matters, it's a permutation. If the order of the arrangement does not matter, it's a combination. Okay? All right. Now, I want to give you a formula for finding permutations. I think I'll just do it on the next page. You can do it on the bottom there, or you can put it on top or on the back of the page, or you can get your own paper out. There's a formula for permutations written this way. And it's saying the permutation of n events n at a time. Yeah. The permutation of n events n at a time, meaning if I have 10 events, all 10 of them are being chosen. When we did the books, at first we had 6 books, right? The next time we had 11 books and we only chose 6 of them, right? Or maybe we had 5 classes, we chose all 5, and then we had 11 books and only chose 6 of them. So they don't always choose all of the objects we have. If we're choosing all of the objects, then this is just equal to n factorial. Factorial, if it was 8 factorial, it would mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All the way down to 1. Okay? If it was 5 factorial, it would be 5 times 4 times 3 times 2 times 1. What we did earlier, when we went 11 times 10 times 9 times 8 times 7 times 6, and stopped there, that's not factorial. Okay? Because we cut out the bottom half. What we were doing in that case was n elements r at a time. Okay? So the permutation of n elements r at a time starts out the same, but we didn't choose all of them, so we have to divide them by n minus r factorial. Okay? So we have to divide them by n minus r factorial. And so if we went back to that other page, I'm not going to, I'm just going to do it down here. But if you go back to that other page, we would see we had 11 factorial divided by 11 minus 6 factorial. What's 11 minus 6? Okay? And so I'm going to take this, move it over here so I have a little room. This is 11 times 10 times 9 times 8 times 7 times 6 times 5. In fact, 5 factorial means 5 times 4 times 3 times 2 times 1, right? So 11 factorial is the same as 11 times 10 times 9 times 8 times 7 times 6 times 5 factorial. And that's divided by 5 factorial. What happens to my 5 factorials? They cancel, leaving me with this. And if we went back and looked at that problem we did already, we would see that that's exactly what we had, right? We had 6 spots for our books, and we had 11, 10, 9, 8, 7, 6. That's what we had to choose from. And so we multiplied them out, and we got 332,640, something like that. Okay, so that's how we could do that. Now your calculator, which I will show you in a few minutes, your calculator will help you do that. It'll do that for you. Okay? I will give you some, though, that I want to make sure you understand how to do by hand. So on your homework, I will expect to see this setup. If you choose to use your calculator from there, that's great. Let your calculator do the whole thing. I'm okay with that. Okay? Jesse, you really should copy this stuff down. All right, combinations. Remember, combinations are when the order does not matter. So when the order doesn't matter, we have all those different permutations, but some of them were the same group of people, right? If I put you guys all in the groups of 4, and then we all switched around again and again and again, you might end up with the same group of 4. So where you sat your table didn't matter to me. That was this combination. And so the formula for that is n factorial. Actually, let me move this down. This is written this way. So the combination of n elements r at a time, n minus r factorial times r factorial. Okay? So here's our formulas. All right? All right. I think I've exhausted. So, listen please. On the front side says study guide, there's a couple reminders of notes, and there's an example of how to do a permutation, 8 elements, 8 at a time, a permutation of 8 elements, 2 at a time, and a combination of, actually they combined counting principle with combination. They did 9 elements 3 at a time and 11 elements 4 at a time. So you can look through those to help you to do the 14 problems on the back. Okay? Now, I'm going to pause while you get your book or your calculator. So while this is finishing loading, if you look at that last example, example 2, the story says the Outdoor Environmental Club consists of 20 members, of which 9 are male and 11 are female. 7 members will be selected to form an event planning committee. How many committees of 4 females and 3 males can be formed? You notice in this situation, they're not saying how many groups of 7 people. They're telling us 4 of them have to be female and 3 of them have to be male. And that's why when you look down at the example, you'll see there's a combination of 9, because there were 9 male, and they're selecting 3 of them, so 9, 3 at a time, times a combination of 11 females, 4 at a time. Okay? Instead of a combination of 20 people, 7 at a time, they have to be split up into 2. And so that's why that looks the way it does. All right. So if I want to calculate, go back here real quick. If I want to calculate the combination of 12 elements, 5 at a time. Okay? 12 elements, 5 at a time. And I haven't used this lately, so oh, here we go. Go to menu. My bad. Grab the wrong one.
No, I think this one's done.
So if you go to menu, go to probability. We were talking about combination. Combination of what? What was my problem? What did my problem say? 12 elements, 5 at a time. So if I go 12, comma, 5. The comma was down here below the pi button, way off on the left. Okay? Now, if I wanted to do the permutations of 12 elements, 5 at a time, then I go back to menu, go to probability, go permutations this time, 12, comma, 5. Oops, I accidentally hit the comma twice. Okay? So do those numbers make sense?
Yeah.
Tell me why they make sense. Why is permutation so many more than combinations? What's that? Counts down in order. Okay. So you're looking at the math, what's happening in the math. I'm thinking more along concept-wise instead of the math of it exactly. In permutation, order matters. So if I have Jimmy, John, and Sally, then if I have John, Sally, and Jimmy, that's different than Jimmy, John, and Sally, right? So I might have the same group. Where Jimmy, John, Sally, John, Jimmy, Sally, John, Sally, Jimmy, Jimmy, Sally, John, Sally, John, Jimmy, Sally, Jimmy, John. There's 6 different arrangements there. In combination, they're all the same, but in permutation, there's 6 different ones, aren't they? So there's going to be a lot more permutations for the same scenario than there would be combinations. Because many of the permutations would count as the same combination. Okay? All right. You have not a lot of time, so get started on that. If we run into trouble, we'll talk about it more tomorrow. If you're at home, you'll just have to study your notes. There's no homework for you. I don't have it online.